Hello students, welcome to today's experiment. Today we are going to look at experiment C8, that is a linear expansion experiment. We are going to determine the expansion coefficient for these three metal rods: copper, brass, and steel. So we are going to start by looking on how this experiment can be done, and will help us to get the data and do the analysis. So we are starting by looking at the methodology on ways that can be used to get this experiment. So the linear expansion experiment, introduction part of it, we see that when a metal is heated, it increases in length. The change in size of materials when subjected to heat is called thermal expansion. So in this experiment, a linear expansion of copper, brass, and steel is measured. The objectives, as we discussed earlier, was to measure the coefficient of linear expansion of brass, copper, and steel. So some of the material that is needed are as follows. We need the expansion apparatus. Expansion apparatus are just apparatus for measuring the expansion of materials independence of length. It has some various parts. It has an inlet and outlet pipe that allows steam to enter and exit the metal tube. It also has a metal tube that holds the metal rod. On another side, it has a dial gauge that shows the amount of expansion when the metal rod is subjected to steam. So this is the expansion apparatus. This is the metal tube. This is the dial gauge, and these are the metal rods. So as we've said, the dial gauge is used to show the amount of expansion when these metal rods are subjected to steam or heat. So a dial gauge is, as you can see, it consists of two scales. We have the outer scale, and we have the, this is called the revolution counter. So this inner scale shows the number of rotations made in the outer scales. Basically, here you can see that it is still at 0 rotation, and the outer scale is reading 68. So to get the reading of this dial gauge, we will take the reading of the revolution counter, that is 0 in millimeters. Then we'll take the reading of the outer scale, that is 68. And then we'll multiply this reading by 0.01 millimeter. That is the precision measurement of this dial gauge. So we also have other apparatus, such as the digital thermometers and the analog thermometers. The working principle of these thermometers are as follows. Digital thermometers, including resistance temperature detectors, thermocouple, and thermistors, are temperature sensing instruments that are easily portable. They also have permanent probes and a convenient digital display. So the working principle of these thermometers are that they consist of sensors that measures the change in resistance due to heat and converts the change in resistance to temperature. So basically, that is how the digital thermometer works. And of course, we have the analog thermometer here. We know that it consists of mercury. So when there's presence of heat, this mercury will expand along the capillary tube, and the reading will be made against the meniscus level and recorded. So we also have another apparatus here, conical flask. Conical flask will be used to heat water. It holds water so that it can be heated to generate steam that would cause the expansion of the metal rod. Here we also have what we call a rubber stopper. This is just a top cover of the conical flask. It will help us to prevent heat loss when the heating process is carried out. We also have a meter rule. Meter rule will be used to take the initial measurements, the initial length of the metal rods before it could be fixed into the metal tube. And also it will be used to take the final measurements of the metal rod after it has expanded. We also have what we call heater, just a source of heat. It will be used to produce heat. And we also have the 3 metal rods that are under study. That is, we can see here we have steel, we have brass, and we have copper here. Yeah, so basically those are the things that is needed in this linear expansion experiment. So the theory part of it is as follows. We know that when a metal rod is heated, the increase in length is denoted as delta L of the material. And this is directly proportional to the increase in temperature, delta T, and to the original length, L1, of the material. So mathematically, this can be written as follows. The change in length, delta T, is equal to the coefficient of the linear expansion, denoted as alpha, multiplied by the initial length L1 times the change in temperature delta T, where alpha is the average coefficient of linear expansion of the metal over the temperature, and delta L is nothing but final length minus initial length, and delta T is just the final temperature minus the initial temperature. And of course, we know that L1 is the length of the bar at temperature T1, and L2 is the length of the bar at temperature T2. So when we replace delta L as L2 minus L1 and delta T as T2 minus T1 in the equation above, we get it as follows. L2 minus L1 is nothing but the coefficient of linear expansion times L1 into T2 minus T1. When we make alpha the subject of the formula, we see that alpha becomes L2 minus L1 divided by L1 times into T2 minus T1. So this formula will be used to calculate the coefficient of linear expansion of these metal rods. So we are going to start by looking on how we can get these readings. So the procedure, we will make the setup using the first metal rod, that is brass. So the setup is here. We have the setup here with us. So here is the dial gauge, as we discussed earlier. here we have the outlet pipe. This will remove the condensed steam. We also have the inlet pipe here, and this is the conical flask. This is the heater. We also have an analog thermometer here and a digital thermometer here. And of course, this is the metal tube. Inside it, we have the metal rod, brass. So this is the process of setting up the apparatus for this experiment. So basically, before heating process, we'll need to take the initial measurements of metal rod, of the temperature here, yeah, so, and also we'll take the reading of the dial gauge. So the initial measurement of the metal rod will be taken using a meter rule. Yeah, so at first here we can take the reading of the thermometer at the initial temperature. So initial temperature of the brass is T1, and as you can see, it's 24.8 degrees Celsius. So we'll make that, we'll record that. Then we also take the initial length of the metal rod, brass. Here is the brass. So you can see the length, the initial length is 56.5 centimeters. So we also make that record. We also take the initial reading of the dial gauge as E1. So as you can see here, the revolution counter or the inner scale is at 0, to mean there's still 0 rotations, and the outer scale reads 68. So the reading, it will be the reading of the outer scale 68 will multiply by the position measurement here and add the reading of the inner scale, and we'll also record that. So we are going to heat water to generate steam and allow steam to heat up the metal rod, and then we'll read or we'll determine the amount of expansion using the dial gauge. So the setup for heating should be set like this. Here we have the heater, dial gauge, water in the conical flask, of course the inlet pipe. Yeah, so you heat it. Yeah, so after heating it, you'll see that steam will be let in using this pipe, and the metal rod here will expand. After it expands, it will cause an expansion in this dial gauge. So then you will be required to take the final readings of the dial gauge, of the final measurement of the metal rod here, and the final temperature of the metal rod. So as you can see, the final length of the brass was recorded as follows. You can see it's here. It's recorded as you can see. We also have the final temperature recorded as indicated here. Then we also have the final dial reading recorded as indicated here. So you record the data for the setup using brass. Then we proceed by using another metal rod, that is copper. So it's all about following the Same procedures. We'll start by taking the initial measurements again, such as the initial temperature of copper, initial length of copper as L1 centimeter. You also take the initial dial setting. As you can see here, the initial temperature is indicated there. The initial dial setting as E2 is indicated here. So you make the readings and note them down. So the heating process is here. We just need to fix in the copper metal rod inside the metal tube and heat up the water to generate steam and check how the expansion takes place using the dial gauge here. Then after that, we also required to take the final readings as follows. Final length of the copper, L1, after it has heated, you require to get the final length, record the data. We also have the final temperature of copper as indicated here. We also have the final dial setting of E2 as of copper as indicated here. So we make the record of all those. Then after that, we also do the same for another metal rod that is steel. We make the setup using steel, just need to fix in the steel in the metal loop and heat the water. And of course, before heating the water, we need to take the initial measurements again. That is the initial length of steel L1, initial temperature of steel T2, and of course the initial dial setting when steel is used. Then we follow the same step, heating the water to generate steam as in the setup below. Then allowing the steam to enter the metal tube to heat up the metal rod, and we'll realize or see the amount of expansion as will be indicated in the dial gauge. Then also we'll be required to take the final readings, such as the final length of steel in centimeter, the final temperature as will be indicated using the digital thermometer, and of course the final dial setting when steel is used as will be indicated in the dial gauge. Then after recording all this data, the student is required to use the equation as indicated in the manual to calculate the coefficient of linear expansion of different metal rods, either by writing a program or using the formula above. Also to calculate the average E2 and average E1. E1 is the initial dial setting. So for us to get the average, the student should take the reading 3 times and get the average. So the same to average E2, take the reading 3 times and get the average. The expansion of bar will be just the E2 minus E1. You're also supposed to get the error in expansion of bar, the temperature difference, T2 minus T1, error in temperature difference. You are supposed to get that. Error in the value of coefficient of linear expansion. You're supposed to get that. So I can say this is all about linear expansion experiment. It was an easy experiment for you are Welcome. Thank you for staying tuned.